Hi, this is Mike Queen from WinCNC, and I'm going to do an outline scan or edge scan on this piece of material. The outline scan can either start in a positive Y direction or a negative Y direction. It can start its initial move in the X positive direction, which on this piece would force it to go in a counterclockwise, or it can go in an X negative direction, which would be a clockwise motion. It will scan all the way around this. Then I'm going to do an inside scan. Then I'm going to scan each one of these holes. And I'm going to put those all together in a file and make this part, or a very close representation to that part. It's very important. It just does not move. I've attached a couple of pieces of tape in inconspicuous places to try to keep it from that. However, there's a possibility that it may, because it's a very light piece. I'm going to now go to File, Digitize, Outline, click it, and I need to browse to where I want to save my file. Let me come back to this. I cannot write a name in here, even a file path, and get this to work. I must click Browse, and since I'm doing the outline scan over again, I will click Save, and I want to replace it. Now it puts the name in here the way it should be, but you cannot just type this in here. It will not work. I want a DXF file. I want an outline scan. I could save it as a CSV, and that's just a point cloud, which some programs use. I want my scan increment to be 1/10 of an inch, which will give me very close to 1/10 of an inch apart on my touches as it goes around. It will not be exactly 1/10 of an inch, though, because of this thing, the way it works. It works in like loops. It will touch, then it will loop and touch and loop and touch. As it goes around that corner, it may have to do more than the 180 degrees it did from while it's going across this flat, so therefore the points will be closer together. Some places they'll be further apart. So I wanted you to understand that. I do not set my feed rate higher than 30 inches per minute because I want an accurate scan. The higher this feed rate, the higher the speed is for the scanning, the less accuracy you get, and also the more likely you are to jar your material as it's going around. And if you jar it, your outline will not be correct. I do not have a good fixture on this, so there's a possibility that my outline will not be correct. I want to do a 360-degree scan here. I do not want a 180. I do not want it halfway around. I want 360. I want to start my scan in X positive direction, and I want my Y initial move to be in positive direction. I could start it from back here, as I have on another video of this same part being scanned, but on this one I want to start it from the front, just to show you that you can do it from front or back. I'm starting with my ball very close to the top edge of this. I want it to be there because I have these tabs sticking out here where I've cut apart from this, and I want to be able to get those in my scan. If this were any deeper, it would maybe hit up here on the actual shaft and not down on the ruby ball. And it's important that it hits on the ruby ball because of the measurement down here that I've taken of the ball. But I'll get to that in just a few seconds. The initial Y move distance is how far I want. See, I'm going to start out in front, and then I'm going to move forward into that. I want to only be able to move a maximum of 1/4 of an inch before it touches. I don't want it to move an inch. I could set that at an inch, but then there's a good chance that I might break my probe if the probe is not enabled in the software. Always a chance that something has become disconnected in the wiring or something like that. So better to only move 1/4 of an inch. The probe can move about 1/4 of an inch without damaging the probe. So I set it at 1/4 of an inch, and then I set the tip about 1/8 of an inch away from the material. That way it's only going to move 1/8 of an inch before it triggers. So now that I've set all this, I'm going to go ahead and run the scan. Well, one more thing. I am telling it to back off 90 degrees after it touches, basically. It says on stuck probe, and it will back off if the probe sticks 90 degrees, but I also use that to back off after I've touched. It'll only back off until the probe releases, but if it's stuck, it'll back right on off until it's moved 1/4 of a turn around. The probe stylus diameter, is the diameter of the ruby ball on the end of the shaft. Hard to see in this video, but if I move out away from the material, you'd see there's a small ruby ball on the end of it. And I do another video that shows that ruby ball and how to measure it. That ruby ball is 0.0787, but we only go to thousandths, and it rounded up to 0.079, which is 10 thousandths difference, so it's almost nothing. Also, the probe trigger adjustment. That's how far the probe has to deflect in order for it to trigger the probe. And in my case, that's 6 thousandths of an inch that it has to move that tip in order for it to trigger the probe. So now that I've got all those set, and by the way, this part is 9 inches by 5 inches, and I'm hoping that my outline scan will reflect that. So after saying all that, I'm just going to click run, and I'll let the scan go ahead and run. You notice that it walked around this corner as it was going. Something I forgot to mention was that when it ends, it comes right back to that same place. So it starts here and ends here. So now we're finished with that scan. Next thing I want to do is lift up. I want to move up to the center one, and I'll just do a Z0 since I've already got it set here. I can do a Z0, hit enter, and it moves to my correct Z height. And now I can move up to about 1/8 of an inch away from that edge. And I know it's tough to see, but right there I'm about 1/8 of an inch away or less away from that back edge of that. And what this will do, it's going to do the same thing. It's going to move forward and touch, and it's going to do a clockwise scan because it's going to go in X positive 2, and it will walk all the way around in this direction and stop exactly back where it is right there. So what I need to do now is come back to my outline scan. Now this one, I'm going to just call this the inner and click Save. And put the correct file name and path in there. I do want a DXF file. I don't think I want to change any settings on this. I'm going to leave everything as it is. My initial Y move is still 1/4 of an inch. Back off 90. The ball is exactly the same size as it was, and the trigger adjustment is still the same. So I think we're good there, and I'm just going to click Run and let it finish that one. And you notice that it's going clockwise now. Once I'm finished with all these scans, I will take them into Aspire and put them together and create one part. And since I know the dimensions of this, I should be able to compare them to see how accurately the scan is. I think this is going to be a pretty accurate scan, but the thing is, I could get a more accurate scan by going to smaller increments. The only thing is that the smaller the increment, the longer it takes to go around something. Therefore, the longer it takes to do the scan. Also, there is a finite size that you can go on this. The probe has to be able to back off far enough to release. So if you went too small, you'd get an error because it just wouldn't be able to back off enough to release. If you notice, well, you really can't see it. It's happening so quickly that you can't see the probe trigger. and it ended. You notice it took a much smaller step right there at the end because it was only that distance away from its start point. So it took a much smaller step to come into that one. And the scan has ended and been saved. Okay, the next thing I want to do is I want to move out of the way. I want to page up. And I'm going to come down to this lower left hole. If you notice, these holes are offset. You'll see it later on when I show you the entire file put together. They're offset over to the left-hand side. I just want to point that out. So I'm going to call this the lower left hole. And I'll page down into that. And I'll go to Z0 again. Enter. I'm going to move up fairly close to that edge on that hole. And I'm going to go File, Digitize, Outline, leave everything as it is. I will change this increment on this one. I'm going to make the increment smaller because we're working with a tighter space there, and I want to try to get as close as I can to be accurate on the size of that hole, so, and the shape of that hole. So I go Browse, and here I'm going to say LL hole, lower left hole, lower left hole. And I click Save, and instead of 0.1 here, I'm going to go half of that. I'm going to go 50 thousandths on the increment size. So I'm going to go at 15 inches per minute to try to get a more accurate scan. So everything else stays the same. And I just click Run. You'll notice a different tone in the machine. That's because it's moving slower. Hopefully my part isn't getting jarred around too much. Maybe I should have fixtured it down. We'll have to wait until it's finished to see. I'm going to do this for the other 3 holes also. And that file is finished. So now I'll back away, lift up, and I'll move over and go down into the lower right hole, LR hole. So I'll say Z0, and now I will go Digitize, Outline, and I'll go LR for lower right hole. I will save, and I'm going to leave everything else as it is because I want these holes to be as identical as I can possibly get them. So I'll just click Run. And that one finished. I'm going to back away a little bit, pick it up in the air. I'm going to move back to the upper right. And I'm going to go page down, get down inside of it, and I'll go Z0. That moves it to the... Now on this one, I'm going to do these top holes just the opposite of what I've done everything else. On this one, I'm going to scan toward the front. I'm going to do my initial move toward the front just to show you the difference, that it will work in either direction. I'll go outline, and on this one, I'm going to go Y negative. And it will come forward and touch instead of going, it will come to the front and touch the hole instead of going to the back and touch the hole. So I'm going to leave everything else the same. So I go browse and I go upper right, UR. Save. And leave everything else the same as it was. And I click run. Notice that it came forward and touched. Also, it's going counterclockwise on these, on this one, where before it went clockwise. Just to give you some idea of the versatility of the program. It really doesn't matter whether you start at the front or the back, or whether you move to the left or right as you go around. The DXF should come out the same in either way. The only important thing is that you get things set up correctly and understand how it's going to work. Close to the end. And you notice it made that small move at the end. So now I'll move out, lift up, move over to this hole, then lower back down into it. And just to show you how easy it is to go back in the other way, I'm going to Z0 it first. And now I'm going to, I know that I'm less than 1/4 of an inch away from that edge, so now I'm going to go back to File, Digitize, Outline Scan, and like I said, to show you how easy it is to change it back in the other way, I just click positive on that, and now it will touch on the back. I go Browse, and this is upper left hole, so it'll be UL hole. So now I've got a lower left hole, lower right hole, upper right hole, and I'm doing the upper left hole now. So I click Save, and everything else stays the same, but I'm going to make it start the initial move in Y plus, so therefore it's going to go a clockwise scan. So here goes, I click Run. After it finishes this scan, I'll take the files and put them together, the DXF files, and put them together in Aspire and create this part. Now they're finished, and now I can just page up, I'll move. It doesn't matter where I move to, but I'll move down and move it down to where we can actually see the ball. Oh, let me try to zoom in just a little here. Go down. Tough to see that ball, but right there is the ruby ball on the end. I'm sure it's not really a ruby, but that's what they call it. That's a 2mm ball, and the diameter on that, on mine, on any 2mm, I guess, should be 0.07874 and continue on. The software rounds it up to 0.079, which is going to be very close to being accurate. And that's all for the video.